Woohoo! It's a great day to be in geometry. I'm Miss Leg Battles, and I'm here today to talk to you about perimeters and areas of similar figures. So, what do we need to know before we begin? Well, first of all, we need to know what it means for figures to be similar. In math, what does similar mean? Well, similar figures have the same shape but a different size. Think about when we project things in the classroom. Similar figures could be an enlargement or a reduction of a figure. When I project something from my document camera, it's small under the document camera. I project it large on the board. But they are similar figures. They have the same shape, a different size. So there are two parts to our definition of similar figures. First of all, the corresponding sides are proportional, and secondly, the corresponding angles are congruent. Now let's look at a specific example. I have an example of similar rectangles. Find the scale factor, which is sometimes called the similarity ratio, the ratio of the perimeters, and the ratio of the areas. First of all, let's talk about that scale factor. The scale factor is the ratio of this width to this width. That would be 2 to 3. So the scale factor is 2 to 3. We could have looked at the widths instead. That would be 4 to 6. Would that be different? No, those are the same because 4 to 6 simplifies to 2 to 3. So we know the scale factor is 2 to 3. Now, what about the ratio of the perimeters? We're going to need to find the perimeters. So we'll find the perimeters in red. Now, let's go back and call this figure 1 and this figure 2. Now, let's find the perimeters. What is the perimeter of figure 1? Well, the perimeter of 1 is, remember, it's twice the length plus twice the width, or you could write 2 times the length plus the width. That's our formula for perimeter. So for this one, it's 2 times 2 plus 4. So 2 plus 4 is 6, and then times 2 is 12. So let's just write a little bit of that down. 2 plus 4 is 6, times 2 is 12. So that perimeter is 12. Now, what about the perimeter of the second one? It is 2 times 3 plus 6. Now, we could just say it's 3 plus 6 plus 3 plus 6. It's all the same thing. So that's going to be 18. So what is my ratio of the perimeters? Well, it is 12 to 18. Oh, wait a minute. That'll simplify. 6 goes into 12 2 times. 6 goes into 18 3 times. Next, we'll find the ratio of the areas. So how do we find area of a rectangle? Well, that's length times width, or base times height. So the area of the first one is 4 times 2, or 8 square units. The area of the second one is 6 times 3, or 18. So now we can find the ratio of the areas. Let's write that. Ratio of areas that's going to be 8 to 18. Oh, that'll simplify also. That would be the same as 4 to 9. So that, we always want the ratio in simplest form. So what I notice is that the scale factor is 2 to 3 and the ratio of the perimeters is 2 to 3, but this ratio of the areas is different. So let's see if we can find a pattern. I've prepared some examples for us, several similar rectangles here. The first rectangle is a 4 by 3, and I've color coded this. There's my original, it's 4 by 3, and then the green one is 6 by 8, the pink one is 9 by 12, and the black one is 12 by 16. So have them all here. It'd be very easy for us to find the perimeter of the original one. It's a 3 by 4. So we're going to say 3 plus 4, that's 7, times 2 is 14. So that perimeter is going to be 14 units. Next, the area is going to be 3 times 4, which is 12 square units. We really can't compare the units here with the ones here. These are units. Perimeter is a linear measure. These are square units. Let's get green and color code. My 6 by 8, the perimeter is going to be 6 plus 8 and then times 2, that would be 28. Are you working it with me? Maybe you can get ahead here. And then 6 by 8, 6 times 8 is 48, so that would be 48 square units. Then we have the pink one, 9 by 12. 9 plus 12, and then multiply it by 2, we're going to get 42 units. And then 9 by 12, 9 times 12 is 108 square units. And then finally we have our 12 by 16. So the perimeter, 12 plus 16, and then times 2 is 56 units. And then what's that area? 12 times 16. That's 192 square units. Now, what I want to do is write the scale factor, the ratio of the perimeters, and the ratio of areas for all these pairs of similar rectangles. And I'm going to use my powers of inductive reasoning and see if I can figure out a pattern. So, let's start with the scale factor here of 1 to the original, okay? 1 to the original, that's 6 to 3 or 8 to 4. Either way, we get 2 to 1. So that scale factor is 2 to 1. What's the ratio of the perimeters from 1 to the original? Well, that's 28 over 14, but you know what that reduces to? That is also 2 to 1. And what about the ratio of the areas? That would be right here, 48 to 12 and 48 over 12. Of course, that reduces to 4 to 1. Next, I'm going to look at 2 to the original. 2 to the original, for perimeter, that's 42. Scale factor first. That's 9 to 3, so that'll be 3 to 1. The ratio of the perimeters, 2 to the original, that's 42 to 14. And that's going to be 3 to 1. And then the ratio of the areas, that's going to be 108 to 12. So that's going to give me 9 to 1. Now, finally, my scale factor for 3 to the original, that's going to be 12 to 3 or 16 to 4, which gives me 4 to 1. Then I have the ratio of the perimeters, 56 to 14. That's also 56 to 14. That's also going to be 4 to 1. And then finally, the 192 to 12, That's going to be 16 to 1. So I want to make my comparisons, use my powers of inductive reasoning. It appears that the ratio of the perimeters are always the same as the scale factors, but the ratio of the areas are different. So I want to see how are they different? How do they compare? What can I do to 2 to 1 to get 4 to 1? What can I do to 3 to 1 to get 9 to 1? And what can I do to 4 to 1 to get 16 to 1? Do you have it figured out? I bet you do. It turns out that if the scale factor of two similar figures is A over B, then the ratio of the perimeters is also A over B. It's the same thing, but the ratio of the areas is A squared to B squared. Now we have just a few examples to look at that'll help you with your assignment. The first one says the figures in each pair are similar. Compare the first figure to the second. Give the ratio of the perimeters and the ratio of the areas. So first of all, we really just need to find that scale factor. So what is the scale factor? Well, the scale factor is 8 to 6. Oh, not really. That reduces, doesn't it? 4 to 3. So the scale factor is 4 to 3. We're also supposed to find the ratio of the perimeters. Okay? So the ratio of the perimeters would be the very same. So if the scale factor is 4 to 3, ratio of the perimeters also 4 to 3. And what about the ratio of the areas? Let's see, we'll color code. That can be green. So ratio of areas, is it the same? No, the ratio of the areas would be 4 squared to 3 squared. And in this case, that's going to be 16 to 9. So if the scale factor is 4 to 3, the ratio of the perimeters is 4 to 3, and the ratio of the areas is 4 squared to 3 squared, which is 16 to 9. In our next example, the figures are similar. The area of one figure is given, and the area of the other figure is what we're looking for, and we're going to round our answers to the nearest whole numbers. So let's begin with scale factor again. The scale factor is 12 to 18, common factor of 6, so that's going to reduce to 2 to 3. That's our scale factor. But you know, this problem is about area. We want to find area. So we need to know the ratio of the areas. Okay, so the ratio of the areas would be 2 squared to 3 squared, which is 4 to 9. Now I can use that to write a proportion to solve for the area of the smaller figure, since we know the area of the larger figure is 121 square meters. So let's write a proportion. 4 is to 9. That's the ratio of the areas of the smaller to the larger. So since we're looking for the smaller, we'll put x in the numerator, and the larger is given to be 121. Now all I have to do is cross multiply to solve. It's going to be 9x equals 4 times 121. So 9x is 484. We're going to divide both sides by 9. And what do we get for our final answer? x is approximately, you put that in your calculator and rounding to the nearest whole number, that'll be 54 square meters. Okay, we're almost there. I have two more examples for you. This one says the scale factor of the dimensions of two similar wood floors is 4:3. It costs $216 to refinish the smaller wood floor. At that rate, how much would it cost to refinish the larger wood floor? So what do we need to know? Let's figure out this, the ratio of the areas. We already know the scale factor, it's 4:3. But if we're going to refinish the wood floor, this problem is all about area. So the ratio of the areas would be 4 squared to 3 squared. That's going to be 16:9. That's what I need to write my equation. If the ratio of the wood floors, the area of the wood floors is 16:9, then the cost will have the same ratio. It costs $216 to refinish the smaller wood floor, so I'm going to put my $216 in the denominator, and I'm going to look for the cost for the larger one. So what do we do to solve this? We cross multiply. 9 times x is 9x, and then 16 times 216. And then we're going to divide both sides by 9. If you got that in your calculator. Okay, let's put it in our calculator. And that turns out to be exactly 384. And of course, this is in dollars. It costs $384. Let's make sure that we've answered the question. At that rate, how much would it cost to refinish the larger wood floor? See, the larger wood floor at $384 is more than the smaller wood floor, which is $216. So my answer makes sense. Last example. Find the scale factor and the ratio of the perimeters for each pair of similar figures. Well, we're looking for the scale factor and ratio of perimeters, but what we know are the areas. Area is 75 square meters and 12 square meters. So what I do know is the ratio of the areas. So let's write that. The ratio of the areas would be, hey, by the way, ratio of areas, remember that's a squared to b squared. That's going to be 75 to 12. Oh, but wait a minute. Not in simplest form. You know, you can put that in your graphing calculator if you want, and it'll just simplify for you. But I know that, let's see, I can reduce this by a factor of 3. 3 goes into 75 25 times, and 3 goes into 12 4 times. So a squared over b squared is 25 to 4. I'll come back and write it there. Because what am I looking for in this problem? I'm looking for the scale factor. The scale factor would be a to b. So how do I find a to b? Well, I know a squared to b squared. So a to b would be, well, if a squared is 25, a would be 5. And if b squared is 4, b would be 2. So the scale factor would be 5 to 2. Now I'm also asked to find the ratio of the perimeters. So what is the ratio of the perimeters? Well, I know the ratio of the perimeters is exactly the same as the scale factor. So it's also 5 to 2. So my question to you is, would these two answers always be the same? I'm sure you know. Well, it has been a great day to be in geometry. I know these are going to help you with your assignment. Have a fabulous day.